The last few weeks we've been talking about the Arduino and specifically initially talking about digital input and output, which is like on or off, true or false, button pressed or not. That's digital. And then we talked about analog input and output last week, which is kind of a variable amount of values that we get to work with depending on the circuit, or depending on the sensor that we're playing around with, whether that's just a simple potentiometer or knob, or a light sensor or a temperature sensor or something like that. It's a variable range of values that we get for the input, and then we could pass that variable range to some sort of output like an LED or a servo motor or something like that. So today we're just going to be doing just a review of digital and analog input and output for the Arduino. So it should be a fairly quick lecture. Feel free to ask questions, or if you want me to demo anything, again, I'm happy to do that. So yeah, feel free to just shout out what you want to see and what you want to review. But we're just going to go through the slides for now. So the first thing we did was just playing around with digital write, which is sending a on or off, true or false, or sending voltage to, in this case, an LED from the Arduino, based off of the code that we have written on, that we uploaded to the Arduino. So again, the breadboard is where we place all of our circuits and sensors. The breadboard is getting power from the Arduino with the 5-volt output, and it's also being grounded by the Arduino as well. So the breadboard is getting power and ground on the power and ground channels on the left and right hand side. We're passing the power and ground from from the left channel to the right channel with these two cables. And then now that that's powered and has ground, we can use those anywhere along the channels for power and ground for any of our components. So here we have an LED. The short leg is going to be plugged into ground. The long leg is going to be connected to a resistor so we don't overload the LED. And then that is also going to be connected to the Arduino, which is going to give the LED power whenever we want it to, based off of the code that we've written. So is that pretty clear? You guys have any questions about that physical setup of that circuit? So when it comes to the code, it's fairly simple. So here we have our setup, our void setup function, and our void loop function. Our setup function just runs once. That's setting up everything that we need when we load the sketch, when we load the Arduino. So for this, we just need to define what the pin mode is for the pin that we're using. So the pin that we're using is pin 3, and that is set to be an output because we're just going to send power to that LED. So we have to say that that is an output, not an input. And then that only has to run once, so that's why it's in setup. And then in loop, we're running through the code that we wrote here that is basically just flashing the LED on and off. So again, digital write is writing a value, writing voltage to the pin 3. And high is saying we're sending it 5 volts, so the maximum amount of voltage that our Arduino can send. And then the delay, we're just leaving it on for 1 second or 1000 milliseconds. And then we're doing another digital write, and then we're writing to pin 3 low, which is sending no voltage, so it's 0 voltage, which is turning the LED off. And then we're sending another delay, so it's going to be off for 200 milliseconds. So the next thing we played around with was digital in and digital out. So before we were just sending a value, sending voltage to an LED. With this example, we're accepting an input from, in this case, a button that's sending voltage to the LED. It's sending voltage to the Arduino that we could then read and then say, okay, we're getting a button press, now do something with that. So here we still have our power, 5 volts being sent from the Arduino and ground being sent from the Arduino to the breadboard. So all that's the same. The LED is the same setup. It's again plugged into pin 3. The only thing that we're adding here is a button. Remember, the button has 2 sides that you could use independently of each other. So you could, I normally straddle the center of the breadboard with this particular button, and then just use one side or the other side. So you could have two different connections to the Arduino if you wanted to. I don't know why you would do that, but you potentially could. But here the button is first connected to power. So it's getting power from the Arduino board through the power rails. And then second is connected to the Arduino. But we are also including a drop-down resistor so we don't send too much power back to the Arduino, which could be potentially harmful to the Arduino. So that's one thing to remember. You don't need to send 5 volts, all 5 volts, the maximum amount, back to the Arduino to get a reading. It just needs a little bit. So it could be like 1 volt, 2 volts. It doesn't need that much. So that's why we use a pull-down resistor to pull down the amount of voltage that we're sending back to the Arduino. So that's what that resistor is for. So now when we press the button, the Arduino would sense that the button was pressed based off of the code that we wrote. And then we could do something by saying, okay, turn on the LED when the button is pressed. So when it comes to the code for a digital input and a digital output, again, it's similar. We have our setup and our loop. Our setup is just going to run once on load. So for that, we're going to include our pin mode, like definitions. So how we're defining each pin that we're using. So again, pin mode 3 is going to stay plugged into the LED. So that's going to be an output. But now that we're using a button, and that's plugged into pin 2, we have to define that as an input. So button press obviously is an input. We're sending voltage, we're sending a value to the Arduino when we interact and press the button. And the LED is receiving voltage, receiving information from the Arduino, so that is an output. So that makes sense. We just have to define those and how we're using them. So that goes in setup. And then in loop, right here, we're basically just adding a if statement, which is just asking a question. So when the button is pressed, we want to ask the question, is the button pressed or is the button not pressed? So that's why we're using an if statement. So we're saying if digital read, so we're reading a value that's being inputted to the Arduino. If digital read on pin 2, which is what the button is plugged into, equals high. Remember when we're playing around with if statements and asking a question, it's 2 equal signs. So if digital read 2 equals high, that means if the button is pressed, if we're receiving voltage from pin 2, then we want to turn on the LED in this case. So we're going to digital write to pin 3 a high value, which is going to turn on the LED. And then the else is saying if essentially digital read 2 is equal to low, if we're not getting voltage, then we're going to turn off the LED by writing to it a low value.
Can you write 2 if-else statements after one another?
Yes. Yeah, you can have as many if-else statements as you want.
How would that look? Because I think I tried it like maybe last week or 2 weeks ago, and I don't know, maybe I like wrote it wrong, but it wasn't working so well for me, or like it kept telling me that it like, I don't know, something was wrong. Maybe I missed one of the like squiggly like parentheses.
Yeah, it's hard to say specifically with what you were doing. I'd have to take a look at the code, but we can do, let me just...
Like after the else, it would just be like another if.
Yeah, so you could do that. So let me pull up. So you could do multiple if statements, just kind of one after the other. So we could say like if digital read and 2 equals high, then do something else, do something else. And then we could just copy that and paste it and say, okay, if another button's plugged into pin 3, then you could just do that as well. And then apply it to another LED. Oops, hold on. There we go. and then just apply it to another LED or something else. Another way to do it is you can do something like another else statement here, and say like if digital read 3 equals high, then do something else and then add another else at the end. So you can chain them like this too if you wanted to. This, depending on how you're using it, might get messy and a little confusing. So the other way might be a little easier and better, because let's see, do another thing. Because this is saying like if digital read 2 equals high, do something else if digital read 3 equals high. But what if both are like pressed? What if both are high? So that could cause some issues if you don't define that in your logic as well. Yeah. So maybe it's probably...
The other one looks easier, maybe.
Yeah, maybe it's depending on what you're doing again. It's hard to say for like just generally what to do, because it all kind of depends on the circuit that you're putting together. But yeah, this might be a little easier for now, having it separated.
Yeah.
But yeah, if again, depending on the circuit that you're putting together, you might want to do it the other way. All right, so that was digital input and digital output. So the next thing that we moved on to was playing around with analog input and output, using the potentiometer, which again is just a fancy way of saying knob. So for this example, we have our LED, which in this case is plugged into pin 9, and our potentiometer, our knob, which is plugged into the analog input A0. The knob is getting power from on one side and ground on the other for the two prongs over here. And then the other one is again plugged into A0 on the Arduino board. The LED is plugged into pin 9. Again, for any sort of analog output, we're using the pulse width modulation, which is kind of fake analog output, which stands for, that's what the PWM stands for, and also that little wavy line. So if you're playing around with analog output values, then you have to use a pin that has a wavy line next to the number. So that could be 3, 5, 6, 9, 10, and 11. So that's what you got to work with when it comes to analog output. And then analog input has to be any of the analog ins on the left-hand side, so A0 through A5. But the rest of the board and breadboard is set up the same. We're still getting 5 volts from the Arduino and ground from the Arduino plugged into the breadboard. All right, so for the code, we have a couple of variables that we're using up here. These are integer values, so that's why it's called an int. And an integer is basically just a whole number. Again, a variable can have any name as long as it's like one word. I'm using camel case here, so it starts with lowercase and then all the other words are uppercase, so you can kind of visually see the difference between each word. But you could also do like underscores. You might be able to do hyphens, but I'm not sure about that. But as long as it's like one string of text with no spaces, then that's fine. It could be called whatever you want. So here we have an integer variable called LED pin, and that's just where the pin is plugged into, set to 9. And then we have an integer value variable analog value set to 0. We're just initializing it. And then integer brightness value variable that's set to 0. Again, we're just initializing it. In setup, we are defining things that we need to load on load. So anything that we need to load once, that goes in setup again. So because we are using analog inputs, we want to use the serial monitor so we could see the values coming in the serial monitor. So that's why we say serial.begin. The 9600 I think is the speed or frequency in which we're receiving data. I always use 9600, but I think you could change that to other values. But let's just stick to 9600 for now. And then pin mode, we're just defining the output pin because the input is going to be an analog input anyway, so we don't need to define that as an input or an output because it's always an input. And we're using the variable LED pin here, which is representing number 9. And again, the LED is an output. Then in void loop, which is, again, we're just constantly looping through this code endlessly until we unplug the Arduino or remove it from power. So we are setting analog value variable to be equal to the analog read for A0, which is what our knob, our potentiometer is plugged into on the breadboard, or sorry, on the Arduino. So that's the value that we're going to get when we turn the knob. And for the potentiometer, for the knob, it's going to be a value between 0 and 1023. The brightness we are recalculating based off of the value we're getting from the knob, because a LED requires a value between 0 and 255. So that's why we're dividing analog value by 4. So the maximum value is going to be 255, and obviously the minimum is going to be 0. And that's the value that we want to send and write to the LED. So for sending analog values to the LED, we have to use analog write instead of digital write. So we're using the analog write function. We're passing in the variable for where which pin the LED is plugged into, which again is equal to pin 9. And then we are passing the brightness value to that LED to make it get brighter gradually and get dimmer gradually based off of the position of where the knob is as we turn it. And then the last thing, actually the first thing we probably want to do is do serial.println and print out the analog value to the serial monitor. So that's usually the first thing I do, just to see what values I'm getting and to see that I am getting values. If it's like all zeros or something like that, then we know that there's something wrong with the connection between the analog sensor and the Arduino. So I normally always start with this line and to see if it's working, and then add to it after I know that I'm getting some sort of values into the Arduino. So there are a lot of different analog sensors out there that you can play around with for your projects. The one we just talked about was just a potentiometer, or just a knob, which is also, all of these are called variable resistors because they change the resistance of the voltage being passed through. Yeah, there's tons of options that you can play around with. Depending on what you want to do, what project you're working on, you'll probably want a different type of sensor than just like a knob or something like that. So here's just a few examples of what you can play around with. Some are in your kit. Others you'll probably have to buy separately if you want to. So again, there's probably a sensor for testing and getting values for anything that you could think of when it comes to measuring something in your environment or doing stuff with like biometrics. So anything that you could think of, there's probably a sensor that you can find and use and connect to the Arduino. I think the only question is how much that sensor costs, how much that component costs, because some are more expensive than others, but the majority of them are pretty inexpensive, so it shouldn't be too cost prohibitive. So these are both temperature sensors. This one, with the black top and the 3 legs, is a part of your kit, and that's just a very basic temperature sensor. This is a little bit more advanced one that's meant for like more accuracy when it comes to measuring the temperature in your environment. These are all different types of light sensors to measure the amount of light in your environment. This is a moisture sensor if you want to measure the amount of moisture that's in like a potted plant or something like that, then you can get one of these. This one is a little bit more advanced. It's called an accelerometer or a gyroscope. and that allows you to measure like precise tilt and angles on an XYZ axis. And these are kind of some biometric sensors that you can play around with. This is the heart rate sensor that I demoed for you last week. And then this is a fingerprint sensor, a fingerprint reader that you can hook up to the Arduino as well. Again, these are just a fraction of the examples out there that you can find. So if you have an idea for the concept that you want to do for the midterm or the final, that requires you to get values from a specific part of your environment or biometric information, then you want to look at some of these sites like SparkFun or Adafruit to see what sensors you can get to measure those values. Yeah, so on the class website, let me just go to that first. So on the class website, if you go to helpful links, so yeah, if you go to helpful links on the class website, towards the middle, there's a section called buying components. So these are all the different sites that you can go to find any of these components. I normally like to use SparkFun or Adafruit. Those are my two favorites. But feel free to look at some of the other places like Jamico or Mouser or DigiKey. I think there's a Micro Center in Queens, so kind of close to campus. So if you live by campus, you could maybe check that Micro Center out. And then Amazon has a lot of this stuff too. I usually try to avoid it just because I don't necessarily want to support them. I'd rather support some of these smaller companies or organizations. But if you need something like in a pinch, need something quickly, then you're probably going to get it faster buying on Amazon than on like SparkFun or Adafruit. So Micro Center has a lot of this stuff too. Radio Shack used to have a lot of this stuff, but they kind of went under. I think you could buy it online too, so that might be a good option. But you can't buy it in the stores, even, I mean, if there are even stores anymore, I'm not sure. So yeah, so all of these are really great resources. Again, I use SparkFun and Adafruit predominantly when I buy sensors and components. So yeah, so for another analog output, we played around with the speaker as well that came in your kit. So if you're interested in doing stuff with audio and kind of making your own instruments, like we basically made a photocell theremin in this class using a light sensor and a speaker. So we're changing the frequency of the tone that's coming out of the speaker based off of the value that the light sensor is reading. So that's basically an instrument right there. So you could play around with creating your own audio projects too if you're really interested in music or just audio in general. So that might be fun to play around with. Again, this was a very simple example to change the frequency based off of a knob, and as we change the knob, it changes the frequency and pitch of the audio coming out of the speaker. The code is very similar to what we've done already, except we have a new function that we're using called tone. It's just like digital output or analog, digital write or analog write, except instead of just passing a general value, we're passing a frequency. And generally a frequency, you want the values between 100 and 800, 880. Anything above 880 is going to be super high pitch, and all the neighborhood dogs are going to howl at it. Anything below 100 is going to be super low pitch, and you can't really hear much of anything. So this is kind of the sweet spot, a nice range. And you could figure out what specific frequency to use for different notes. So if you wanted to create your own digital piano or something, and specifically have, when you press a button, have the frequency be a C or A minor or something like that, you could figure out what frequency that is and apply that to the output of whatever button press you're doing or whatever you're doing. So yeah, so there's a lot of fun stuff you could do with audio too, and tone and frequency. So we also talked about using the servo motor. The servo motor is great if you want to have specific accuracy over the angle of the arm of this motor. So if you wanted to wave a flag or point an arrow at a board, in a specific area. You can use the servo motor to do that. For this example, again, we just hooked up a little potentiometer, a knob to control the angle of the motor. And again, servo motors, most servo motors only allow you to go between 0 and 180 degrees for the turn. So that's kind of your minimum and maximum range for the arm of that particular servo motor. And then for the hookup, the Arduino, the servo motor is plugged into ground with the black cable. The red is plugged into power. And then the yellow, I think mine was white, is the one that's plugged into the Arduino. And again, because we're using analog output, or a fake analog output with the pulse width modulation, it has to be plugged into one of the output pins that has a squiggly line next to the number. And this is the first project that we did that required using a library. So we had to use the servo library to create a servo object, and in order to control the direction and angle of the arm movement on the servo. So we're including the servo library, and then we're creating a servo object. This is very similar to like a variable. You just give it a name that you want to call it. We called it servo motor. Below that, we're just creating a variable called servo pin for where the output pin is that the motor is plugged into. In setup, we're setting up our serial, and we are also attaching the servo pin number, which is 9, to the servo motor object. So we're saying this servo motor object is plugged into pin 9. And then in loop, we are looping through and getting the value of the knob. So as we turn it, we're getting different values. Using analog read, again, it's plugged into A0. We're printing those values to the serial monitor so we can see what values we're getting. And we're creating a variable for servo angle, and then remapping that value to be go from a min of 0 and a maximum of 1023, which is what we get for the input of the knob, to the angle that we are able to use with the servo motor, which is 180 degrees, but with programming we start with the 0. So it's 0 to 179 degrees. So that's what we're remapping the value to. And then we're passing that value to the servo motor itself by doing servo motor.write, and then the angle that we want from the value that we're getting from the knob. And then we also briefly talked about the H-bridge, but we also have talked about documentation and data sheets. So data sheets for different components. So anything that's a little bit more complex of a component or a sensor probably has a data sheet associated to it. Even if it's not like complex, like an LED probably has a data sheet associated to it. And that data sheet tells you how to use the component and the amount of voltage that is required to activate it, and the maximum amount of voltage that it can handle before it gets fried out. So data sheets are really important, especially when you start getting into more complex components like the H-bridge. The H-bridge is a little bit more complex. So make sure if you are working with something new that you look over the data sheet before you start just sending it voltage, because you might fry it. And then we just briefly talked about the H-bridge and what it does. Essentially, it can switch between, change the direction of the voltage or the current. So if we want to change the direction of a motor, then using code, we can plug the motor into the H-bridge, and then through code we can send a value to the H-bridge to say, okay, turn the motor to the left or turn the motor to the right. So that's basically what an H-bridge is used for. Here's some code. We're basically just saying we have 2 pins. Both pins are output pins. The H-bridge is plugged into 10 and 11. And then in our loop, we're just writing a high to 10 initially and a low to 11. So it's going to turn the motor in one direction for 1 second. And then after that, we're just flopping it and saying low to 10 and high to 11. So it'll switch the motor and spin in the other direction for 1 second and just go back and forth. So I don't know if you remember the little CD-ROM agitator I made, but that's all it's doing is it's flipping the direction of the current for the motor to go back and forth and turn, open and close the CD-ROM drive. So another thing that we haven't really talked about is our relay switches. And relay switches are a component that allow you to control AC current. So if you wanted to play around with AC current, which is a high voltage and can potentially be dangerous, so just be cautious and be aware and be very careful. But like, for example, I used relays for my light hum project where I was converting light waves into audio waves, and I was basically controlling the light bulbs using relay switches to turn on and off the light bulbs. So like if you wanted to control a lamp or something that requires AC power, then with an Arduino, then you would have to use a relay switch to basically send it AC current or not send it AC current based off of the switch that's in here. This one is like it's a physical switch in this box, so it's like a gate that opens and closes based off of sending it a DC current from the Arduino. And this one is similar, but it's using a laser to open and close that AC current. Again, so on one side is going to be connected to the AC cables and wires, and the other side is going to be connected to the Arduino. So if you send this like 5 volts, then it's going to open the gate for the AC current. If you don't send it 5 volts, then it's going to shut it. So relays are great if you want to use play around with AC currents and AC circuits. So yeah, so this is a project that I did using relays. So there's a bunch of solid state relays in here, and then when I give this like a current, then it opens up the gate and passes the AC current through this to turn on the LED. If it's not getting a current, then it closes the gate and the current, the circuit is broken and it doesn't pass AC current through it. So that's how I kind of worked with this, just playing around with relay switches. So this is the interior of this box, essentially. So some other components that are helpful to know are, these are called screw terminals. So if you are working with components or things that have like a lot of wires to it that don't necessarily fit into the breadboard, then you can use screw terminals. So the wire would go inside this terminal and you would screw it down. So this little piece of metal would go down and make a contact to the wire. And then this portion here, these legs at the bottom would be plugged into your breadboard or circuit somewhere. So screw terminals are helpful for that purpose. If you are dealing with delicate components like a photocell sensor, a light sensor, or like an LED, and you want to extend or add a wire cable to that LED or light sensor to extend like the length of how far away from the breadboard it can be, you can use this tool. It's called a wire wrapping tool to wrap a wire around the leg of that component to extend how far it can be from the breadboard. For most other components, you're probably going to want to do something like solder wire to the legs to extend the distance in which it can be away from the breadboard or your just circuit board in general. And solder is basically just metal that you can melt at a high temperature or fairly high temperature that when it solidifies, it makes a solid connection between a component and a circuit board, or a component and some a wire extension. So I don't know if you guys, I think some of you bought soldering irons. If you don't have one and don't want to buy one, there's plenty of soldering irons at the makerspace on campus, so feel free to go there and use them if you're comfortable. But yeah, soldering is a helpful method to learn to extend the distance in which you can place components. So soldering kind of makes it more permanent. Wire wrapping is also fairly permanent, and it extends just adds longer wires to some of your components. And then screw terminals allow you to plug things into the breadboard or a circuit that might not fit through the hole. This is what I want you to work on. I want you to start thinking about what you want to do for your midterm project, and start brainstorming ideas, start sketching ideas in your notebook, to kind of figure out what you're interested in and what you want to do. And then also think about the sensors and components you want to use for your midterm projects, as well as how you want people to interact with it. So I guess we haven't talked about like proximity sensors. There's proximity sensors too. So if someone walks up to it and gets close enough, then it'll activate something. So there's a lot of different ways that someone can interact with it. It could be as simple as a button press or multiple button presses. But yeah, so that's basically what I want you to start working on. All right, so that is all I got for you guys today.